everyone, it's Miss G and I'm here with you this afternoon, and we're going to be talking about our second type of transformation, and that is reflection. So think about looking in a mirror and you get your reflection. That's what we're going to be talking about. So our objective for today is we're going to determine what properties are preserved when an object is reflected. And we're going to walk away with being able to reflect an object over the x-axis. So what is a reflection anyway? Well, with a reflection, we flip an object over a line of symmetry. So that's an important key piece of information there. It's an important vocabulary word, line of symmetry. And a reflection can occur over any line on the plane. So let's take a look at an example. We're going to begin by reflecting an object over the x-axis. So I'm going to go right ahead and I'm going to highlight this x-axis. It's a horizontal line. And so that means we're flipping this object up and down. So from top to bottom or from bottom to top. It's a horizontal flip. So what observations can we make based on the diagram above? So I want you to pause the video and come back and hopefully you jot some things down, some things that you've noticed about the diagram. Okay, well hopefully you pause the video, and one of the things that stands out to me right away is that the objects are congruent. So they're the same size and shape. Another thing that stands out to me is that if I look at A, which is here, -2, 1, and A prime, I notice that they're equidistant, or they're the same distance from the line of reflection, which is the x-axis. So they're the same distance from the x-axis. And then if I look here, I also know that we've got some prime notation here. So we have my prime notation that's indicating my image. Prime notation. And if they're congruent in the same size and the same shape, that means the perimeter and the area remain the same. The angles and line segments also remain the same measure. And a reflection is another type of rigid motion. We talked about that when we discussed transformation. So right now we're talking about rigid motions, and we have another type of transformation which will also be a rigid motion, but not all of them that we study will be a rigid motion. And we'll get to a couple that change. Actually, we'll get to one that does change. So let's practice reflecting over the x-axis. So the directions say reflect the image over the x-axis, labeling our new points with primes. So once again, those points with primes are going to indicate our image. So I'm going to come in here and I'm going to draw my line of reflection, which happens to be right here. I'm going to highlight that in pink so that you can see it. And if I were to fold this paper in half right along the line of reflection, I know that this is going to be moved from top to bottom. So top to bottom, if I were to fold it right across. I'm a little bit off there. Top to bottom, there we go. That's a little bit better. So if I'm starting off in quadrant 3, this is going to end up in quadrant 4. I'm sorry, quadrant 2. So I'm starting off in quadrant 3. It's going to flip back up into quadrant 2. So take a look at the coordinates of the original figure. N is -9, -3, so fill these in, please. O is -2, -3. P is -4, -9, and M is -7, -9. So take a second and to fill those in. And so we already talked about the objects being equidistant from each other. So that's the way we're going to flip this to begin with. So if I notice here that N is 3 units away from the x-axis, N prime is going to be 1, 2, 3 units away. So I'm going to go ahead and label that with N prime. And O is 1, 2, 3 units away. O is going to be 1, 2, 3 units away. O prime. And then P prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my P prime. And my M prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the same thing here. 4, 5, 6, 7, 8, 9. And there's my M prime. Taking my straight edge, you're always going to use a straight edge when you draw your shapes in, or your figures in. And definitely, I find it very helpful to have a highlighter or some other sort of color pen so that I can identify what the line of reflection is. You don't have to, it's just a little thing that helps me out. And I'm going to highlight that in pink so that it stands out to you a little bit more. So let's list the coordinates of the image. So I see that O is going to be -2, 3. N is going to be -9, 3. P is going to be -4, +9. And M is going to be -7, +9. So what do we notice between the two sets of coordinates? Well, if I look at this, if I look at my x-coordinates seem to remain the same. But if I look at my y-coordinates of each here, my y-coordinates look like they change up a bit. So we can simply say that the y-coordinate is negated or changes the sign. So let's look at this a little bit more in depth. I'm going to put this off to the side, and let's take a look at what remains the same between both of the figures. So looking at this, it definitely looks like they're the same shape and same size, so that means they're congruent. So we can say they're congruent. Same shape and size. I can also see that the side lengths are the same. So if I look at MP, MP is 1, 2, 3, and M prime, P prime is 1, 2, 3. So that the side lengths are the same. And I also notice that MP is parallel to NO, and the same is true up here. MP is parallel to N prime O prime. So I can also say that the side lengths are the same measure. It's definitely equidistant because that's how we reflected it. The same distance away from the x-axis. We know that the sides are parallel. And that's a special word called parallelism. So another mathematical term, parallelism. And we also know that the perimeter and area will remain the same. So I'm going to squeeze that in over here. And it's equidistant from the line of reflection. So what changes? Well, let's take a look at what does change. If I take a look at my original figure, I go from N to O, O to P, P to M, and M to N. N to O to P to M. In that clockwise fashion. Well, if I go up to my reflected image, I start at M prime, and I go to P prime, so I'm going right around in a circle. Then I'm going to come down to O prime, over to N prime. So notice here that the orientation, the order of the letters has changed. So I'm going to come back over here and write that the orientation has changed. So let's think if there's a shortcut or a rule that we can use to determine a reflection over the x-axis? Well, if I look at my original coordinates here, it looks like I'm keeping my x-coordinates the same, but I'm negating or changing the y-coordinates. So let's go ahead and write that down. We keep the x-coordinate the same, and we negate or change the sign of the y-coordinate. So what this looks like is xy becomes x negative y. So what I'd like for you to do is pause the video once again and jot down some things about what will remain true about the shape that we are reflecting. And then tomorrow when you come to class, we're going to have a little chat about that. What will remain true about the shape that we are reflecting? So hopefully you'll pause the video, and now it's time for you to try one on your own. So Melissa drew the shape on the grid below. Draw the reflection of the shape in the x-axis. Label the coordinates of each point on the new figure. So here's my x-axis. Go ahead and draw that. This is going to be a horizontal flip, top to bottom. Pause the video and come back and check out what we have. So hopefully you pause the video, and whether or not you decided that you're going to use the coordinates or the rule or not, or if you just continue to count the boxes, that's totally up to you. So our shape should be here. A prime is 4, negative 2. B prime is 2, negative 6. C prime is 4, negative 8. And D prime is 6, negative 6. So take your ruler, take your straight edge, whatever you have, make sure that's drawn in nice and neat. And everything is labeled with the coordinates. And once again, we're going to come down here and just rewrite those coordinates for us. So A prime is going to be 4, negative 2. B prime is 2, negative 6. C prime is 4, negative 8. And D prime is 6, negative 6. So check it out, and I'm going to go ahead and highlight that in pink so we can see it. And to sum up the properties, the only thing that changes with a reflection over the x-axis is the orientation. And let's think about what stays the same. It's the same shape and size. The angles stay the same. The line segments stays the same. They're congruent. All of this means that they are congruent. And parallel lines stay parallel to each other, so we have parallelism. So tonight, as we step away, what I'd like for you to do is think about it. Think about the 3 important things that we need to know about a reflection. So I hope you guys have a great night, and I will see you tomorrow in class. I'm going to play some music out. Have a fabulous evening, and thanks for being an awesome audience. See you tomorrow, everyone. Bye.